Highly host students, Mr. Kaczynski with you, coming at you from the Simpsons living room. Let's get going on 3.5, practice your skills exercises. Okay, we're going to copy and complete the table of input and output values for each equation. We'll do this a few different ways. Obviously, this can be done by hand. So we could do 50 plus 2.5 times 20, which would be 50. Let's see, 2 times 20 is 40. Half of that would be another 10, so 50. So that would be 100. You know, we can do that over and over again, but I think I'm going to use my technology a little bit more. So let's go 50 plus 2.5 times 20. And that's 100. I could hit second enter and I can change that 20 to a negative 30. That's negative 25. Let's change that negative 30 to a 16. That's 90. And then a 15. Well, I know that that's going to be 2.5 less. 87.5. And lastly, negative 12.5. Which is 18.75. All right, let's do a different route here for B. Negative 5.2 minus 10x. Let's go to the y equals function on our calculator. Let's do negative 5.2 minus 10 times x. And then let's go second table. And you can see right there, it gives us a table of values. So 0 is negative 5.2. We can scroll up to negative 8 and see that it's 74.8. Let's take care of these negatives. Let's do negative 35. Not sure that this is necessarily quicker in this case. We get 344.8. If I want to jump straight to 24 without scrolling all the way, I can do second and then window is table set, and I can tell it that I want it to start at 24. And then go back to my table, and it starts right at 24. So it would be negative 245.2. The problem is we don't have decimals, but we kind of do. We can do second window for table set. I can say that I want to start at negative 5.2, and I want it to go by 0.2s, the change in the table. That's what that triangle means. It's delta table, change in table. So there's 46.8. All right, I think I'll just go back to the main screen. Well, you know what? This is a little bit different because now I actually have to undo these operations. So let's do this once by hand here. Let's do negative 10 equals 4.7 plus 3x. So I need to add take the negative 10, add 4.7 to it, to both sides of this equation. That gives me negative 5.3 equals 3x. And then I'll divide the negative 5.3 by 3. Boy, that's an ugly number, negative 1.76 repeating. But it's going to be those same two steps every single time where we're subtracting 4.7 and then dividing by 3. So let's start with negative 2, subtract 4.7 and divide by 3. And we get negative 2.23 repeating. We'll start with 4.7, subtract 4.7. Obviously, when we divide by 3, we're going to get 0. Start with 6.2, subtract 4.7, and divide by 3. Get 0.5. And then lastly, start with 21, subtract the 4.7, and divide by 3. 5.43 with the 3 repeating. All right, enough of that. Use the equation y equals negative 29 plus 1.4t, where t is the temperature, w is the wind chill, both in degrees Fahrenheit, to approximate wind chills temperatures for 40 miles per hour. Okay, let's use the table here for sure. Let's go negative 29 plus 1.4 times x instead of t. It really doesn't matter. For t equals 32 degrees. So we want to go to, I got to reset my table here. Let's start at 32, and we'll go by 1 degree every time. And that's going to be W equals 15.8 degrees. That's what the temperature would feel like with the wind chill. Okay, find T when W equals negative 8. So that would mean we'd have to go to, it's somewhere right in there in between 26 and 7. So we could graph this. Let's go from 0 to 50, and from 0 to 50 for our wind chills. We could trace it. Oh, we're looking for negative 8, so I probably that's okay. Can't see it, but I'm looking for when y equals negative 8. So you can see it's right about at 14.9. Or we could just go back to the main screen. We could type our negative 8, and then we could undo it by adding 29 and then dividing by 1.4. And this is going to give us the exact value, which is exactly 15 degrees. What is the real world meaning of the 1.4? All right. So how about the wind chill goes up 1.4 degrees each time the temperature increases by 1 degree. This is specific to 40 mile per hour winds. So when there are 40 mile per hour winds. So that's our constant rate of change. All right, what's the real world meaning of negative 29? So this would mean that the wind chill, apparently that's 2 words, and I spelled temperature wrong up there. The wind chill is negative 29 when the temperature is 0 degrees and there are 4. So that's our starting amount, kind of, even though temperature can go below 0. Fix those 2 mistakes. All right, number 3, describe the rate of change of what the rate of change looks like in each graph. So the graph of a person walking a steady rate towards a motion sensor. So I'm thinking about this graph right here towards a motion sensor. So if they start here, they're going to get closer to the motion sensor. So what's that look like? A straight line, first of all, because they're walking at a steady rate, a straight line that is going down or getting closer to the y-axis, or the x-axis rather. The graph of a person standing still. So we've talked about this one a few times in class. That's going to be if they start this far away from the motion sensor and they stand still, they're not going to get any closer to it. So we'll just say that that's going to be a horizontal line. The graph of a person walking at a steady rate away from a motion sensor. So if they start this far and they walk away, they're going to get further away from it. So this is basically the same as answer to A. It's going to be a straight line that is going up. And the graph of one person walking at a steady rate faster than another person. So I guess we're talking about the fact that a straight line with a steeper slope than the line that represents the other person. So it's going to be a steeper slope since they're walking faster. Since they don't tell us whether it's towards or away, it really doesn't matter. They're both going up. It's just going to be a steeper slope. Using the input variable x and the output variable y, sketch a graph picturing Percy's location over time if he starts at 34 and moves 6 units to the left with each jump. All right, so we're just going to sketch a graph here. So let's go 5, 10, 15, 20, 25, 30, 35, 40. And this is going to be our outputs, whereas our inputs are our jumps. So we'll go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 jumps. This should get enough data on the table for us. All right, so he's starting at 34, which is right about there at 0 jumps. 1 jump later, though, he's going to be, let's use a recursive rule here. Let's go 34, that's our start, minus 6. So he's going to be at 28, which is right about there. 2 jumps, 22. 3 jumps, 16. Then 10 after 4 jumps. And then 4 after 5 jumps. And then -2 after 6 jumps. And -8 after 7 jumps. So something like that. We'll get the job done. That equation, by the way, would be y equals 34 minus 6 times whatever x is, even though they didn't ask us for the equation. All right. Hopefully that helps you, and I hope you have a great day. Contact me or Mrs. Kraft if you have any questions. Bye now.